Well, good evening, everyone, and welcome here to the launch pad and our live launch coverage of the first ever flight of Vulcan Centaur with ULA. You're looking at a live view of Slick 41 at Cape Canaveral Space Force Station in Florida. This view coming in from our rocket chaser Gavin, who is down on site as we continue to count down now, just over 51 minutes and counting till launch. If it's your first time here, welcome. My name's Zach. I'm the founder and host here at the launch pad. Here at the Launchpad, it's our mission to inform and inspire the explorers of tomorrow because we believe that space is better together. We're glad to have you joining us here live tonight. Ooh, we got the camera back there. There we go. If it's your first time, take a moment, engage that like button, share out the stream, and let us know in the chat where you're watching from. Got people tuning in all over the world, and we're glad to have you joining us here. It's a late one for us here in North America, but pretty nice time for those over in the UK and Europe. We got Windbreaker in Arkansas. Good to see you. Matt is in Alabama. We got Ted in Poland. Great to have you here. David's on Earth, so that's fantastic. With no aliens yet. Great to have you here. Anthony's in the US. We got Bacon in Minnesota. Some old dude is in Indiana. We got Carrie in Connecticut. And I'm going to say your name wrong. Yashodahan. I'm so sorry. From India. It's great to have you joining us in here live as we continue through the countdown. Propellant loading began a number of hours ago on Vulcan Centaur and is well underway. We had an update from ULA not too long ago, weather 80% go for today's flight. As always, here at the Launchpad, if you guys have questions, you can send those in the chat by tagging us at the Launchpad, and we'll work on answering those live. We are counting down to when ULA will begin their live coverage, and once they do, we will patch them in as well. T-minus 50 minutes and counting till liftoff. Today's flight is just south of a easterly straight east launch trajectory, so if you do happen to be anywhere in Florida except the Panhandle, you do have an opportunity to see today's flight within the first few minutes of flight. Tonight is carrying a very special payload, as this is the first of 2 certification flights, but there's no dummy payload on board. Today's flight payload is Astrobotic's Peregrine lunar lander, carrying a wide variety of payloads for NASA, about 6 other countries, and even some of the first ever normal people commercial payloads to the moon. Some of our friends, TJ Cooney that did the I Need More Space name submission program, Astro Liz is on board, Ian Sager's program's on board, and a number of others are flying as part of this mission. So super excited to know I and a number of our family's names are on board for today's flight, and excited to see those people's payloads finally fly and land on the surface of the moon. Now, we're not landing on the moon today, and we're not even landing on the moon this month. Lunar landing scheduled for February 23rd, and once we are right before liftoff of Vulcan, we will begin our live tracker, where we will be tracking Peregrine over the next month and a bit, waiting for that lunar landing on February 23rd. It's going to spend a fair amount of time in lunar orbit before it actually touches down, but it's a big moment because this is the first U.S. lunar lander since 1972. So the U.S. finally going back, and it's not a government lander. It is a commercial lander that's heading back, and it's the first of many coming out of Astrobotic. If you guys have questions, you can send those in the chat by tagging us at the Launchpad. We got lots of people tuning in. Gary's in Washington State. Raptors in Salt Lake City is Brian. We got Mapper in Kazakhstan. PS is in Western Australia. White Rabbits in Wisconsin. Teapot is from Toronto. We got Juan in Venezuela. Great to have you all joining us here. I know I'm a little bit smaller on the screen tonight. We wanted to put all the focus on Vulcan, as that is what is today's mission. It is a historic mission, and we are so excited to have that view. ULA is, not that one. We were looking at the weather, but ULA is getting ready to go live here, and once they do, we will patch them into the feed as we continue through the count. They are beginning their live coverage here, T-minus 47 minutes, 30 seconds, and counting till launch. Once they begin their commentary, we will listen in to them for an update on how things are progressing through today's countdown for Peregrine 1 aboard the first ever Vulcan launch. Weather's been looking pretty good all day. We had that earlier Starlink launch, so things have looked well throughout the day for propellant loading. Let's listen in to ULA Mission Control as we count down to the first ever flight of Vulcan Centaur.
The This is a live view of United Launch Alliance's new Vulcan rocket on Launch Pad 41 at nearby Cape Canaveral Space Force Station. It will launch a spacecraft that will land on the moon, making it one of the first lunar landings for the U.S. since the final Apollo mission over 50 years ago. Good morning, and thank you for joining us on the Space Coast of Florida. I'm NASA's Megan Cruz, and you are watching the first launch of NASA's CLPS initiative. CLPS is short for Commercial Lunar Payload Services, a model in which NASA contracts space on commercial missions to send science and technology to the moon. These deliveries will mean more exploration of the moon than ever before and will help us prepare for the first woman and first person of color to land on the lunar surface under NASA's Artemis program. For today's launch, NASA selected Astrobotic to deliver its 5 lunar instruments. This is the first mission for the Peregrine spacecraft. Today is also the first launch of ULA's new Vulcan rocket, so a lot of firsts today. Now we have a 45-minute launch window that opens at 2:18 and 38 seconds Eastern time. But you'll notice that clock on the upper left-hand corner of your screen. It says T-minus 7 minutes. That's because the ULA team is in a planned hold. Basically, they baked extra time into the countdown to make sure everything's good for launch. You'll see that clock start to count down again when we are actually 7 minutes to the opening of the launch window. Helping me to share today's
Ooh, we have some interesting mic sounds there. I'll cut in T-minus 45 minutes, 20 seconds and counting. And I want to make a note on their launch countdown. They have it set to the official T-minus countdown, which is what's holding at that 7-minute mark. Our countdown is L-minus, which we should update that it says T, but it is L-minus. And we do that so you know the real world time for launch. So you know, you have an idea if you have time to go get a drink or you have to go wake up those little ones so they get to see today's maiden flight. So we got that updated. L-minus 45 minutes. Technically T-minus 7 minutes and holding, but that's part of the launch countdown. Let's listen back into Mission Control.
The ULA team is currently not working any issues, and we're on track for an on-time launch at 2:18:38 a.m. Eastern. Coming up, Space Launch Delta 45 will provide a final weather briefing in about 15 minutes. At the moment, our weather looks good, with just a 15% probability of violation through the 45-minute launch window we have available this morning. Now, I'll send it back to you, Megan.
Thank you, Amanda. It's great to hear that 85% go for tonight. Now let's take a closer look at the Peregrine 1 spacecraft. It's about 6.2 feet tall and 8.2 feet wide, made mostly of aluminum and carbon fiber. The 4 landing legs have a honeycomb design on the inside to absorb Peregrine's touchdown on the lunar surface. Its solar panel is mounted to the top of the spacecraft. The payload decks at the center will carry 20 payloads from 7 countries. And finally, it has over 1 mile of cables and wiring. Our broadcast on NASA TV today will cover Peregrine separation around 3:09 a.m. Eastern Time, followed by acquisition of signal shortly after. For more on the company that built Peregrine, here's Astrobotic's Olivia Chapla.
Thanks, Megan, and thanks to all of you for tuning in. I'm Olivia Chapla, and I can't tell you how pleased I am to be here representing Astrobotic as the Director of Marketing and Communications. We're a small but mighty team of about 260 people. Together, our real goal is to make space accessible to the world. And today, we are particularly focused on the moon. Astrobotic built the Peregrine spacecraft as part of our fleet of lunar landers designed to deliver cargo, called payloads, to the moon's surface. Over the past 3 years, I've watched the Astrobotic team build this Peregrine spacecraft launching today. I've been there alongside them during the long days, late nights, and for the ridiculously early mornings when we shipped Peregrine to Cape Canaveral in preparation for launch today. I am personally so excited to be here because this mission really marks the beginning of a historic time. The United States hasn't soft landed on the moon since NASA's Apollo program more than 50 years ago, and only a handful of countries have ever successfully landed on the lunar surface. Astrobotic's aim is to not only return the American flag to the moon again with Peregrine, but also to start regular commercial lunar deliveries to the moon's surface. Now, let's hear a little more from our founder and CEO, John Thornton.
And if you're just joining us, welcome here to the launch pad and our live launch coverage of the maiden flight of Vulcan Centaur carrying the first ever Astrobotic lunar lander, the Peregrine lander. Your first time here, welcome. My name's Zach. I'm the founder and host here at the launch pad, and below me you can see a live view coming in from our rocket chaser Gavin, who's down there on the Space Coast ready for today's flight. As Astrobotic said, this isn't their only lander they are working on. They are working on other rovers and landers, including the Griffin lander and others in the future that will be a key part of the Artemis program. But first, they need to prove that they can. So today we have Peregrine heading off, as they said, with over 20 payloads from 7 countries, including one payload with the DHL Moonbox. First ever private commercial. Regular people can buy space to send something to the moon, and as I said, we know a number of people, including Astro Liz from the UK, including Ian Sager, who's been on the TLP a number of times, as well as a few other people that have payloads on board, including flying I and some of our TLP crew and families' names on board today's mission. As we continue through the count, T-minus 41 minutes and counting. If you guys have questions, you can send those in the chat by tagging us at the launch pad, and we'll work on answering those live to the best of our ability. You heard there that weather has improved from 80 to 85% go for launch for today, which is a really great sign that things are progressing well, and they'll be continuing to monitor that throughout today's countdown. You also heard there that, as they said, this is the first lander from the United States since 1972. Apollo left the moon. Now we are going back, but not with a government lander, with a private lander launching from a private company. Really exciting to see not only a lunar lander heading to the moon, but also see a new rocket unveiled for the first time, having its first flight. This is the first of 2 certification flights for Vulcan, which in the future we expect to actually fly crew with Dream Chaser, but that's going to be longer down the road. We will be tracking Peregrine on its journey to the moon, so we hope that you will join us on that live tracker to check in on updates on the lander. Its landing is currently scheduled for February 23rd, but it will be in lunar orbit for a number of weeks in advance of its actual lunar landing. Now, not only is Peregrine carrying a payload, but Vulcan itself is also carrying. There are some payloads on board the second stage, which are carrying the DNA of not only Tori Bruno and his family, but I believe there's some presidents and some other people on board. And that second stage will fire one more burn after separating from Peregrine and be ejected into a solar orbit, keeping it out of the Earth's orbit, making sure that we don't have any issues of it floating around our planet for decades or centuries to come. Now, just under 40 minutes and counting till launch of Vulcan. We do have a poll in the chat. We want to hear from you guys. How do you think today's launch will go? Of course, we're all hoping that we see an absolutely perfect launch. And we're not talking about the lander at this point. Just launch. How do you think it goes? Do you think we're going to see that dreaded S word, which we're not going to say? Or do you think we're going to, unfortunately, maybe see a RUD or some other failure during flight? And we want to know from you when. Is it going to be the first stage, and is it going to be those BE4s from Blue Origin? Or is it going to be on the pad or during second stage flight, which I feel much more confident on both of those aspects? Or do you think we're going to see Peregrine deployed and a successful first flight of Vulcan? The world doesn't have a great history with first flights, with only, I believe it's 3 out of the last 20 rockets globally that have flown on their first flight. Did they have a successful payload deployment? So we want to hear from you guys. Take a moment and let's listen back into SpaceX, or not SpaceX, ULA and NASA Mission Control.
To explain, I have Joel Kearns here. He's the Deputy Associate Administrator for Exploration in NASA's Science Mission Directorate. Good morning, Joel.
Hi, good morning, Megan.
So talk to me about why we want commercial companies sending our science experiments. Why don't we send them ourselves?
Well, NASA is really good at sending robotic science probes throughout the solar system. But it takes a lot of effort, it takes a lot of time. And for our big push to do science and technology on the moon as part of Artemis, we wanted to take a new approach. We wanted to tap into the new ideas, the entrepreneurial spirit, and all the engineering innovation that these small companies and startup companies bring in the United States. We think they can help make the overall moon effort much better.
But isn't it riskier for us to depend on others versus us doing it ourselves?
There is a different level of risk that we all had to understand and agree to when we started down this. Like I said, we understand how to do robotic science missions at NASA, but we do know that these companies have a lot of good, interesting ideas. By partnering with several different companies for different lunar landing missions, we get to see all their individual strengths, their different technical approaches, but at the same time, we don't get the level of information and we don't have the level of control or direction that we're used to having at NASA. But we think that trade is really worth it.
But why is it so important for us to send science before we send astronauts? We didn't do that before with the Apollo program.
Well, it's been many decades since Apollo, and there were many, many unanswered scientific questions about the moon, not just about the moon itself, but how the moon is almost a time machine to look back to see what happened at Earth in the earliest ages of Earth. So, for example, we can do studies at the moon to try to determine when did all those last big meteor impacts take place? Because if we see them in the moon, they actually happened at the same time at Earth, maybe around the same time life was forming at Earth. You could also look at the moon, and we might be interested in using water ice that's at the south pole of the moon, we expect, for our astronauts in the future. But understanding how that ice got there, how that water got there in the first place, will help us understand how do we have water at Earth that we get to use today.
Real quick, is there anything in particular that you are most excited about discovering on the moon?
Oh, well, there's just so many things. There have been scientific questions for decades that people, scientists in the United States, around the world, have been dying to get back to the surface of the moon to do. We've sent many probes in orbit around the moon, like Lunar Reconnaissance Orbiter, but they look at it from afar. This is going to be our first chance to go back and really make those measurements that really touch the surface and see what's really there.
Joel, thank you so much. I know we have ambitious goals here at NASA. I can't wait to see what we do.
Oh, thank you. This is an exciting day.
Yes, thank you so much. All right, so let's head back over to ULA's Amanda Sterling for another update on the Vulcan rocket.
Things continue to go as planned as we look forward to the launch of ULA's first Vulcan rocket. We're still holding at T-minus 7 minutes as part of our planned 60-minute hold, and the team is not working any issues at this time. The Vulcan booster is fueled to flight level with super chilled liquid oxygen and liquid methane. Soon, Centaur topping to flight levels will begin, and the ULA team is on track for an on-time liftoff at 2:18:38 a.m. Eastern. We're about 5 minutes away from Space Launch Delta 45's final weather briefing. At the moment, our weather continues to look good through the 45-minute launch window we have available this morning. The excitement is building here in ULA's Advanced Spaceflight Operations Center as we get closer to T0. Back to you, Megan.
All right, we're about 35 minutes away to the opening of today's launch window. Inside Vulcan's payload fairing is Astrobotic's Peregrine spacecraft. Astrobotic is based in Pittsburgh, Pennsylvania, where folks there are laser focused on Peregrine right now. Right, Olivia?
That is definitely right, Megan. I'm checking in on our Peregrine lunar lander with our mission control team right now. You can see them on screen. A reminder that our spacecraft is currently sitting in the top of ULA Vulcan's fairing. Our flight director is informing me that Peregrine is looking nominal with temperatures currently at an expected 70 degrees Fahrenheit. We also monitor the environmental pressures around the spacecraft, and we're sitting at a good 14.7 psi. Things are looking good for launch. The spacecraft is currently powered off, but will automatically power on once it separates from Vulcan's payload fairing. And here you can just see the faces of some of the engineers who have worked many hours on Peregrine to get it to the launch pad today. Sitting in the middle left row is Flight Director Anders Solorzano. He is the acting flight director for this launch. And nearby is Alex Van Hoven. He is currently providing us updates on the spacecraft status. And Alex just informed me that the spacecraft is currently looking nominal. Temperatures and pressures are still as expected. As we continue to await launch, let's send it back to Megan at the host desk.
Thank you, Olivia. Again, Peregrine is flying with 20 payloads today. 5 of those are NASA's, and throughout the show, we will tell you about each one, starting first with the Linear Energy Transfer Spectrometer, or LETS, from NASA's Johnson Space Center.
I'm a physicist and professional engineer, science and operations lead for the LETS payload. The Linear Energy Transfer Spectrometer is a small, low-power radiation detector based on Timepics technology developed at CERN. It's similar to devices that we've flown on ISS.
And if you're just joining us, welcome here to the launch pad. You can see there, taking a look at our on-site camera on the left side of your screen. Vulcan fueling up on the pad. They're getting ready to top off those tanks. The flight levels, we were looking over at the flare stack at Slick 41 there a moment ago. As we continue, we're soon going to say goodbye to our on-site camera as Gavin gets ready to capture Vulcan's maiden flight. Let's listen back in to NASA and ULA Mission Control.
Werkheiser, Director of Technology Maturation. Good morning to you.
Good morning.
So tell me how STMD, that's the shortened version of the directorate there, tell me how it invests in small business like Astrobotic.
Of course. So the Space Technology Mission Directorate, our mantra is technology drives exploration. So if you're really going to create new disruptive technologies that change the world, you really have to work with a diverse group of individuals, and that means our small businesses, large businesses, international partners, other government agencies. Astrobotic is a shining example of that. STMD has been working with them for well over a decade. We've awarded over 40 Small Business Innovation Research Awards and our tipping points to develop new technologies for the mission.
So is that essentially like seed money? Is that how to
yes,
consider it?
We're partners, right? We're partners in this. We say at Artemis we're going together, and we mean it. We're invested hand in hand in this.
And how have those financial awards, how have those helped Astrobotic?
So, for example, not only do we have science and different payloads aboard the mission, but actually parts of the lander itself, like our navigation Doppler LiDAR that helps with the guidance, navigation, and control, terrain relative navigation that helps to make sure that they can land in safe spots. You know, the moon can be very treacherous. And also the axial thruster engines on the lander itself are brand new engines that have never been flown before that we're testing on the moon together.
How does it feel to see technologies that your directorate developed, you know, helping us get back to the moon?
There are not words. I really get goosebumps. And, you know, the funny thing is, if you had asked me as it was a child, of course, it's the amazing engineering and science feats that we see happening. But as a child that was raised in a family of a small business, doing this together with small businesses, this being our NASA and going together to the moon, is really just incredible.
Yeah, just what do you think about that? Again, that we're bringing in as many as we can with us back to the moon.
You know what I think? I think that means success.
Yeah.
I think it's going to require all of us and our mutual strengths to make it happen.
Thank you, Nikki. I really appreciate you being here, and I hope you see a beautiful launch today.
Me too. Let's go.
All right, we're just about under 31 minutes to the opening of today's 45-minute launch window. After Peregrine 1 today, Astrobotic will deliver another payload for us, and that's our Viper rover later this year. Towards today's 45-minute launch window that opens at 2:18 and 38 seconds Eastern Time. The ULA team remains in a planned hold and right now working no issues. As for the Peregrine spacecraft, let's get another check of it from Olivia with Astrobotic.
Thank you, Megan. As you may recall, we are currently only monitoring the spacecraft's temperature and pressure while it sits inside the Vulcan rocket's payload fairing. And we're checking in with my team members in Mission Control and Alex Van Hoven, one of our flight directors in the very back row. He is providing us updates directly. Our mission team confirmed the spacecraft's levels are nominal and we continue to be ready for launch. And I'd like to take this time to say a well-deserved shout out to the entire Astrobotic team in Pennsylvania, California, and even a few remote workers. I'm sure you're all watching right now, and we thank you for your continued commitment to this mission and to lunar exploration. We really, really couldn't have done it without you. Now, as we sit tight for launch, we'll continue to monitor Peregrine. For now, back to Megan at the host desk.
A few minutes ago, I told you about NASA's LETS payload flying on Peregrine today. Now we'll learn about NIRVIS, or the Near-Infrared Volatile Spectrometer System from NASA's Ames Research Center.
And if you're just joining us, welcome here to the launch pad and our live launch coverage of the first ever flight of ULA's Vulcan Centaur. We are at T-minus 26 minutes, 5 seconds and counting till launch, and propellant loading is well underway. That live view we had coming in from Gavin, he's getting all set to actually capture the launch, so we've shut down that view for now. It was doing some testing, and thank you so much to everyone's generous support earlier to help us make some upgrades to that equipment, bring you even better coverage as we continue through the count. They're playing some lovely videos with copyrighted music, but we are continuing to count down to launch. We remain at that T-minus 7 minute mark and holding on the T0 countdown. But above me is the L- countdown, and that's the real world count. T-minus 25 minutes, 30 seconds, and counting till launch. At the T-minus 7 minute mark on our countdown, that's when the ULA official countdown will resume and pick up. They can hold there longer if they need to, though, all dependent on how things are progressing. Music Crabs, thanks so much for becoming a suborbital explorer. Appreciate your support there. If you guys are interested in helping us support our mission to inform and inspire the explorers of tomorrow, you can consider hitting that join button. Let's listen back in for more updates as we continue to count down to launch.
Services launch, but now we want to turn the broadcast over to ULA. Amanda Sterling will walk us through the rest of the Vulcan rocket's inaugural flight through launch and ascent, and then Olivia and I will be back around 15 minutes after liftoff to continue monitoring Peregrine. ULA will join us in just a few seconds.
And NASA doing the handover to ULA as they get ready to kick off their live coverage. T-minus 24 minutes, 30 seconds and counting. ULA's big slogan for this is that it's a new rocket, but it's the same DNA. It's all built on the same history of the Delta II, the Atlas program, and the Delta IV Heavy. And now Vulcan is ready to fly. Let's listen in to ULA Mission Control.
Good morning. I'm Amanda Sterling, a program management leader and your host for ULA's live coverage of the inaugural Vulcan launch. I'm joining you from ULA's Advanced Spaceflight Operations Center at Cape Canaveral Space Force Station in Florida. Thanks for staying up late or getting up early with us for today's exciting first launch, Vulcan's Certification Flight 1, or CERT 1. This is the first of 2 planned test flights to support full certification of the Vulcan rocket for U.S. government missions. On board the Vulcan rocket today is Astrobotic's Peregrine commercial lunar lander on a mission to intercept the moon, and the Celestis Memorial spaceflight payload Enterprise, flying to deep space with the Centaur upper stage. Liftoff is scheduled for 2:18:38 a.m. Eastern, and we have a 45-minute launch window this morning. In addition to watching our webcast, you can also follow the live mission progress at ulalaunch.com. About 30 minutes ago, the count entered a 60-minute planned hold. We have 2 planned holds in our launch count, which give our team additional time to resolve any issues prior to entering the terminal count. At this time, the team is not working any issues, and we're proceeding towards an on-time liftoff. We're excited to partner with NASA on today's live broadcast. Together, we'll be continuing our coverage through end of mission. Building on more than 120 years of combined Atlas and Delta launch experience, ULA's Vulcan rocket introduces a balance of new technologies and innovative features to ensure a reliable and accessible space launch service. Let's hear more about this incredible launch vehicle from ULA Business Development Director Tom Burkholder, and Vulcan Chief Engineer R.J. Sansom.
So RJ, can you discuss a little bit of when you began the design of Vulcan and what that meant?
Yeah, when we started the design of Vulcan, we were looking at our national security space customer and designing a launch system that would meet their needs. And we focused on being able to provide lift for the most difficult, stressing mission, which is a high energy mission. We designed a launch system that's flexible. We have the ability to add solid rocket boosters, take them off, to tailor the performance that we need for that particular customer's mission. We have an extremely capable upper stage in the Centaur 5 that provides performance that exceeds all the capabilities that our customer needs. And in the end, we've got a launch system that exceeds all of our national security customers' requirements and enables us to provide performance for commercial customers or other customers that will meet their needs now and into the future.
That's great. And as we look at how the customer received that vision, we definitely saw that they were aligned with it as they contributed to the development from the Space Force to NASA and commercial customers. And so I was wondering if you could also talk on the partnerships that you had in the development.
Yeah, from the beginning, we partnered with industry partners who have expertise and capabilities to help us bring new innovative technologies, as well as to leverage existing technologies. So we brought a very capable yet new design forward that was a low-risk option. We partnered with Northrop Grumman on development of new solid rocket boosters. The first variant of that flew on Atlas with a tailored version that was tailored to provide specific performance for Vulcan. We partnered with Rocketdyne on development of RL-10 and implementation on that, again, first flight on Atlas and then flying again on Vulcan. Partnered with Beyond Gravity on composite structures, and then we partnered with Blue Origin to develop a new main stage propulsion system, the BE-4, the first Oxford stage combustion engine developed domestically. So, industry partners brought a lot to the table for us.
That's great. And then as we look at what this has meant to the market, it's been fantastic. And I was wondering if you could share with me how the Vulcan design has evolved as we've started to look at the commercial market with Project Kuiper.
Yeah, we had a really capable launch system to start with, and as we looked at the commercial market and the focus on LEO, we decided that a small change to our design, a small change to the upper stage would give us increased performance and ability to lift more spacecraft to the low Earth orbit and really position us well for supporting the Kuiper contract and our Kuiper customer.
Yeah, and the result of that was the largest launch contract ever. And so with that, Vulcan has positioned ULA to help support national security, NASA, and our commercial market. So we're very excited about the future. Go Vulcan, go Centaur, go Cert-1.
I'm now joined by ULA President and CEO Tori Bruno. Tori, thank you so much for joining us on this monumental day. I've been a part of the Vulcan team for a number of years, so I know how focused the whole ULA team has been. Can you talk a little bit about the teams that came together to design, build, and now launch this rocket?
I am so proud of our people, and I think we had exactly the best possible team. We've got folks that designed rockets before, like Atlas and Delta, but we also have the majority of our team, people like yourself, that are earlier in their career, know the new tools, aren't sort of handcuffed by some of the conventions that we used before, and can do really creative and innovative work while also not making the mistakes of the past.
Absolutely, and Vulcan is such a unique rocket. What are you most proud of about this vehicle?
I'm really proud of the fact that we still service the high energy marketplace, a unique thing that is really important to our nation's security, that no one else has an architecture that will do that, while at the same time breaking all the rules and having the dial-a-rocket architecture that gives it the flexibility to reach down into that LEO marketplace and be very competitive there as well.
Absolutely. So we're getting pretty close to liftoff now. How do you expect to feel watching the Vulcan rocket lift off for the first time?
Tremendous excitement and anticipation. I got to tell you, I've done over 400 launches. They're all the same. I always get butterflies. This one's really special because of what it means to our country, to our customers, and to the team that has worked so hard, including you, Agent Sterling.
Well, thank you so much for joining us. We'll let you get back to it so you can make sure you watch Liftoff, and let's go.
Go Vulcan. Thank you.
On board the Vulcan rocket today is Astrobotic's Peregrine commercial lunar lander. Peregrine is the first spacecraft in NASA's new CLIPS initiative to have American companies send its science experiments to the moon.
Astrobotic is a full-service lunar company. It starts with our terrestrial testing and development services that can build and test propulsion systems on Earth, to the sensors that make precision landing possible, to our rovers that will deploy down on the surface of the moon. The big thing that we're known for is our 2 lunar missions to go to the surface of the moon. Our first one is about to launch, and our second one flies in 2024.
And if you're just joining us, welcome here to the launch pad and our live launch coverage of the first ever flight of Vulcan Centaur carrying the Peregrine lander. Quick note that I caught in this video, our first flies in 2024, or our first flies now and our next is in 2024. We're in 2024. I think this video might have been recorded a little bit ago, but we're excited to see Vulcan finally out on the pad, fueled up, ready to go. Peregrine is go for launch. It's currently powered down as a lunar lander, but once it has stage separation and payload separation, it will then turn back on. So some big milestones ahead. Not only do we have to have liftoff today, we have to have a successful payload separation and then acquisition of signal from the lunar lander. And the TLP crew, we're watching this one just as excited and eager as so many of you and so many of the team, because not only are our names flying on board today's lunar lander, but we will be flying on a future Astrobotic lunar lander, Lunex-1, our first ever payload going to the moon. So it's a big deal getting to see kind of the first one flying ahead, and we are so excited to Peregrine 1 now finally out on the pad. If you're just joining us, we are now under 15 minutes and counting till launch. ULA currently holding T-minus 7 minutes. This was a planned 60-minute hold, and they will resume that count once our countdown clock and theirs match. That is when the count will resume. We will have a final go, no-go polling. That should occur here momentarily as we continue through the countdown, but weather continuing to look good. Weather improved from 80 to 85% go for launch. Let's listen back into mission control.
Flight control, LC.
Go ahead, this flight control.
Reduce Vulcan hydraulics to standby.
Roger.
Today's rocket includes the American flag across the inner stage, as well as logos on the payload fairing representing ULA, Vulcan, and Astrobotic. While this is the inaugural launch of the Vulcan rocket, the CERT-1 flight test marks ULA's 159th launch. Let's learn more about this innovative new rocket.
And as we continue through the countdown, T-minus 13 minutes, 30 seconds and counting till liftoff. If you guys have questions, you can send those in the chat by tagging us what's in the chat with what at the launch pad, and we'll work on answering those. I was reading someone's question, Lucius, what's on board? Well, we're going to run through it as they continue to talk a little bit more about what they are running through here today. But there's a number of payloads, 20 payloads on board Peregrine 1. That is the lunar lander by Astrobotic. Now, some of these payloads actually are carrying more than just a singular item. So some of these are rovers, some of these are landers, so there's lots to dive into about what's actually on board here. There are 2 lunar rovers on board. One is from the country of Mexico, and the other is from the United States. The US one is called Iris. Now, on board, there are also a number of instruments, and a number of these are actually part of the Artemis program with NASA. NASA is sending a laser retroreflector array, a linear energy transfer spectrometer, a navigation Doppler LiDAR, a near-infrared volatile spectrometer system, a neutron spectrometer system, a Peregrine ion trap mass spectrometer, and a terrain relative navigation. On board also as an instrument is one from Germany with an M42 radiation deflector, or detector, excuse me. Now for the time capsules on board, or payloads, there are a number from various countries. From the United States, there's a Bitcoin magazine Genesis plate. There is Luna 02 from Celestis. There's a Memorial Spaceflight Service from Elysium Space. We also have Moon Arc from Carnegie Mellon University, and we have the ARC libraries from the ARC Mission Foundation. Now from Canada, there are 2 payloads on board, Lunar Codex from Incandescence, and Writers on the Moon from writersonthemoon.com, with stories from over 133 different authors. That is a Canada-US joint one. Super excited to see Canada sending something to the surface of the moon. There's also the Footsteps on the Moon by Lunar Mission 1 from the UK, Lunar Bitcoin by BitMEX from, I'm not sure, the Republic of the Calasis. Sorry if I'm saying that wrong. It's a small, it's 115 small islands in the Indian Ocean. We also have the Lunar Dream Capsule from Astroscale in Japan, the Memory of Mankind on the Moon from the Pulley Space Technologies in Hungary. We have the Your Photos on the Moon from Argentina. We also have the DHL Moonbox from Germany. Also, and part of that DHL Moonbox, there are a number of payloads, including Astro Liz from Leicester's sending one of her Astro Liz stickers. We have Ian Sager's Send Your Name option. There is also one from a number of other different YouTubers and companies that gave people the opportunity to send different things on board. And that was the first time a private civilian anywhere in the world could actually send something that they've held to the surface of the moon. And we're super excited to fly on a future Astrobotic launch in the near future. T-minus 10 minutes, 25 seconds and counting till launch. Looking back into ULA Mission Control.
This morning's launch is looking good. The probability of violating launch constraints is 15%. Ground winds are 15 to 20 knots out of the north, and the temperature is 57 degrees Fahrenheit. The primary concern for launch is the thick cloud layers rule.
minus 11 minutes.
You just hear a call out there, L minus 11 minutes, so our clock's just a hair off. We do have that good old time delay that we work with. So we're going to remove our countdown clock as theirs will begin.
We remain in the planned 60
ticking
minute.
here in just a couple of minutes, T-minus 7 minutes and holding, but we are about 4 minutes away from when that clock will resume, and prior to that, we will have the final readiness for launch poll. Let's listen in.
Are polled for system status and readiness to proceed. This is the final status check for all Vulcan vehicle systems, ground systems, spacecraft, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Dylan Rice performs the final polling.
Prior to the status check. L minus 10 minutes. Status check to proceed with terminal count, Vulcan systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LNG.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Hazgas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GC cubed.
Go.
Operation support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. ALC. Verify T0 is set for 071838 Zulu.
Verified.
And you heard it there. We have a full green board of goes across the way, and launch has been authorized. T-minus 7 minutes and holding. That count will resume shortly as we are counting down now the final minutes until the maiden flight of Vulcan Centaur, carrying Astrobotic's Peregrine lunar lander to the surface of the moon. We're continuing to listen into Mission Control for the latest updates, but you can see that beautiful paint job of the flame and the red is all frosted white as Vulcan is now fully fueled and ready for launch.
Minus 25 seconds, you'll hear Go Vulcan, Go Centaur, Go Peregrine. This is the final status check of rocket and payload readiness. At T-minus 7 seconds, Rofi sparklers will ignite, followed a second later by initiation of the launch pad water deluge system. At T-minus 3 seconds, the main engines ignite. Then, after seeing Vulcan's first ever liftoff from Slick 41, you'll begin hearing flight commentator Rob Gannon providing launch vehicle ascent data. This is Vulcan Mission Control at T-minus 7 minutes and holding. We anticipate releasing the hold in just a few moments.
On my mark, the time will be T-minus 7 minutes and counting. 3, 2, 1, mark. 6:55. Ground pyros enabled.
The countdown clock has resumed, and we are go for launch at 2:18:38 a.m. Eastern. After liftoff, ULA's Vulcan rocket will head east from Space Launch Complex 41. Here's a look at today's ascent.
Show us the rocket, ULA. Show us the rocket. T-minus 6 minutes, 20 seconds and counting till launch. Vulcan's clock is now running. That was the final hold in the count. We heard greens across the board for today's flight and authorization to launch here as we continue through the count. T-minus 6 minutes, 5 seconds and counting. If you haven't yet, take a moment, engage that like button, share out the stream, invite people to join us. This is the maiden flight, a brand new rocket that's going to be a huge part of the upcoming space program, launching from the East Coast, and maybe eventually we'll see Vulcan launch from the West Coast as well. But this is the first of 2 certification flights. The second one we expect to happen, and then we will see Dream Chaser flying on board Vulcan in the near future, hopefully as well. Vulcan has a large number of contracts carrying a variety of military, government, and commercial payloads into orbit, into the moon, and we are super excited to finally see it out on the pad, ready to fly. T-minus 5 minutes, 20 seconds, and counting. You're seeing here an animation of what the launch will look like. Now, there's not that many SRBs on Vulcan for this flight. There's only 2, I believe. That's what they require, but Vulcan can have a combination of 2, 4, 6, or no SRBs attached to it, all dependent on what the payload is. T-minus 5 minutes and counting till launch. If it's your first time here, though, welcome. My name's Zach. I'm the founder and host here at the Launch Pad, and here at the Launch Pad, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together, and we invite you to engage that subscribe button so you never miss another live launch coverage, docking, undocking, or return to Earth. Now, you're seeing on the animation there a rough timeline of how things will progress. After liftoff, you're not going to want to go anywhere. Peregrine separation scheduled 50 minutes, 26 seconds into flight. So stay with us through that time, as we do have a couple burns of the upper stage called Centaur, and then we actually will have Peregrine deployment. Then we have to wait for Peregrine acquisition of signals. So not only are we holding our breath through launch, but we need to wait and hope that Peregrine actually wakes up and begins its sending signal to begin its journey. Here you're looking at those milestones that will occur where spacecraft separation will happen. And then MES-3, that is actually where the second stage will perform a third burn, sending it off onto a solar orbit, carrying a few payloads itself, and making sure that we do not clog up our low Earth orbit area. T-minus 3 minutes, 50 seconds and counting. As always, we do a go, no go of our community in the chat. If you're a TLP member, don't forget you have those TLP emojis that you can use. And we do have a couple fun ones for tonight. You do have that ULA one, of course, a go, no go. So we invite you to use those as we continue through the count. T-minus 3 minutes, 30 seconds and counting till the maiden flight of Vulcan. Let's listen back into ULA Mission Control. T-minus 3 minutes.
$249. FTS internal. $238. $230.
CLO2 PLP started.
$159.
Vehicle internal.
T-minus 2
155.
minutes. The launch vehicle, payload, ground systems, and eastern range are go for launch. For those of you just joining, I'm Amanda Sterling, and I'm your host for today's live coverage of the inaugural Vulcan rocket launch. The team is not working any issues, and we're on track for an on-time liftoff at 2:18:38 a.m. Eastern Time.
FCS armed. $120. FCS count started. One minute.
T-minus 1 minute.
Range status.
Range green. $45.
Vulcan tanks at step 3.
$30.
BE4 start box, go.
Status check.
Go Vulcan.
Go Centaur.
Go Peregrine.
15. 10.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. And liftoff of the first United Launch Alliance Vulcan rocket, launching a new era in spaceflight to the moon and beyond.
Engines operating. 2 good SRBs, hitting peak pressure on the SRBs. Everything looking good. And we've got pitch and yaw programs in, coming into normal rates for that event. We have good hydraulic pressure on both engines. Good chamber pressure on both engines, everything looking good. Coming up on 60 seconds into the flight, everything looking good. 2 good engines, 2 good SRBs. Body rates look good, nice and smooth. And we've hit our first throttle point on the BE4s, everything looking good. And we have passed through Mach 1, we are now supersonic, coming up on max Q. We've had max dynamic pressure, everything looking good, we're rolling off on the SRBs. And we have cutoff on the SRBs, coming up on jettison in approximately 30 seconds. $15 seconds to SRB jet, BE4s continue to operate nominally. Seeing expected PU activity on the booster mains. And we have separation of both SRBs, everything looking good. BE4s continue to operate normally. Coming up on 2 minutes into the mission. We are now 17 miles in altitude.
We just heard confirmation of solid rocket booster jettison. We have about 3 minutes until we reach our next mission event, booster engine cutoff.
And we see booster PU correcting towards a nominal MR, everything looking good. Both engines continue to burn normally.
Just joining us, you're looking at a live view from onboard Vulcan, flying for the first ever time. The SRBs have jettisoned, and we are now
weighing
flying
approximately half of our liftoff weight. Everything looking good.
flying with just 2 of the SRB. The SRBs
And
are
we
gone.
fired
And
the
just
power valve, activating the reaction control system.
Just 2 Blue Origin
On the upper
BE4s now
stage,
powering
pressures are
the first stage of Vulcan. 2 minutes 45 seconds into flight.
PE4 continues to operate normally. Vehicles continue to fly down the center of the range track, everything looking good. 33 miles in altitude, 52 miles downrange, traveling at 4,000 miles per hour.
Another minute 45 seconds of burn on the booster. And then they will have Bico at
Excellent
stage
performance
7.
out of the BE4s. Chamber pressure nice and smooth. Vehicle steadily accelerating, a little over 2 Gs at this time. Good body rates. Nice and smooth operation of the booster. 47 miles in altitude, 95 miles downrange at 5,500 miles per hour. Engines continue to burn normally, everything looking good. And the vehicle now weighs 1/4 of its liftoff weight as we pass through the Kármán line. Next mark event we're looking for is boost phase chill down on the Centaur main engines.
I'm going to call it out right there, and I'm going to talk over him. You heard him there, Kármán line. Vulcan has officially passed the Kármán line on its first ever flight.
Normally.
That is a major milestone in a new maiden flight of a new vehicle. 20 seconds left on the burn of the
And we've begun boost phase
booster.
chill. Housing temps are dropping as expected. Coming up to the end of the boost phase, approximately 10 seconds to BECO. Throttle down in preparation for BECO. We've completed boost phase chill down, and we have cutoff. Coming up on Vulcan Centaur separation. We have Vulcan Centaur separation. Everything looking good. Coming up on the Centaur phase. And experiencing a bit of data loss here. We've recovered the data. It's like Centaur engines are up and running normally, good steady state pressure, and we've just jettisoned the payload fairing. 2 good brake wires.
Peregrine now exposed to the vacuum of space for the very first time. First U.S. lunar lander in 50
steady-state
years.
operating levels on the Centaur mains.
On its way.
2 good engines. Gone to open loop control on Centaur PU.
This is Vulcan Mission Control at T plus 5 minutes 57 seconds. We just heard flight commentator Rob Gannon confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. Our next event, main engine cutoff, will occur in about 10 minutes. While we wait, I'm joined by Amanda Pichetti, ULA Director of Vehicle Upgrades. Amanda, thank you so much for joining us, and I know it's still early, but congratulations.
Thank you, you as well. This is amazing.
How did it feel to watch the Vulcan rocket lift off for the first time?
Oh, just absolutely amazing. I didn't expect it to be the way it was. It just, my heart is still pounding. It was excellent, and just I'm so proud of all the work that the team did to get where we are today.
Absolutely, and developing a new rocket is an enormous endeavor of which you were a huge part. Again, we're still early, but how do you imagine the whole Vulcan team is feeling right now?
I feel like they have to be the same way, smile ear to ear. I know the team is at all our sites, friends and family. They've been supporting us for many years to get to where we are, so I'm sure they are jumping up and down just like me. It's been amazing.
How is the Vulcan rocket going to change the industry?
Yeah, that's a great question. So Vulcan is very much based on our heritage rockets, the Delta IV and Atlas V vehicles, but we've brought in a lot of new innovation and capabilities that are going to allow us to even better support our warfighters, exploration, as well as connecting the world. And the great thing about Vulcan is it's highly versatile, meaning we can use that vehicle to do anything we want, allows for affordability for anybody who needs access to space.
Absolutely. And so this is the first certification flight. What are the next steps for Vulcan after this?
Yeah, so with the first flight, we are well under the way from a certification perspective. We do have a second flight that we'll need to do here later this year. Once that completed, we'll have about 2 months or so of post-flight data testing, and then at that point we will be certified by the U.S. Space Force, and we will be ready to fly all of their important payloads for them.
Awesome. Well, again, thank you so much for joining us, and we'll let you get back and watch the next mission events.
Congratulations again.
Thanks, you too.
Coming up on 500 seconds into the mission. Everything's looking good. Continuing to burn Centaur. Body rates right as expected. Steady acceleration, just under half a G. And we are now 235 miles in altitude, 836 miles downrange, traveling at 11,150 miles per hour. Continue to see nominal performance from Centaur. And approaching the halfway point of this first burn of Centaur, everything looks good. We're now 1,000 miles downrange, traveling at 11,500 miles per hour.
This is Vulcan Mission Control at T plus 10 minutes 7 seconds. Our next event, main engine cutoff, will occur in about 5 minutes. While we wait, I'm joined by Eric Monda, part of ULA's mission design team. Eric, thanks for joining us.
Hi, Amanda. Thank you for having me.
Of course. So we're still pretty early in this flight today, but can you tell us how the data's looking so far?
Yeah, absolutely. So I just want to say that it was so exciting. I ran outside so I could watch this thing lift off, and that was so cool after so many years of development to watch this thing fly. That was fantastic.
Absolutely, I bet.
Yeah.
So what is the data showing us so far?
Yeah, absolutely. So I've had a very quick look. Obviously, we're very early in the flight still, but I've taken a look at the SRB performance as well as the booster performance so far, and everything looks just spot on, just perfect. Fortunately, we've had a lot of these systems on Atlas and Delta for a long time, and so we've had a lot of flight data to anchor our models, and everything is lining up just like we would expect.
Awesome.
Yeah.
So a lot of the audience has seen us switch from this live view of the launch from our rocket cam to this animated representation of the vehicle in space. Can you talk a little bit about why we make that switch and how this visual is populated?
Yeah, absolutely. So when we first lift off, we have a feed directly from the cameras that are on the rocket back to the launch site here. And so with that, we can get the video feed that we need in order to provide those images. As we get further downrange and we go over the horizon, we no longer have that direct link. And so we rely on NASA's TDRS system to send telemetry from the vehicle back down to us on the ground. In that telemetry data, we get information like position and attitude and velocity, And so we use that to drive the animations you see here.
Okay, so we're looking at real data, what's happening. It's just a graphic of it instead of the real thing.
That's exactly right, yes.
Awesome, that's really cool. So, today right now we're in the first of 3 Centaur burns. Can you talk a little bit about why we need 3 burns and how we use those 3 burns to complete our mission today?
Yeah, absolutely. So the first burn performs our injection into low Earth orbit. Unfortunately, if we just continue that burn from that point in time, we wouldn't necessarily be aligned with where we need to be in order to get to the moon. So what we do after we get to low Earth orbit is we shut those engines down, we coast around until we get to the right spot to do that, and then we light those engines up again. When we do that and complete that burn, that will allow us to send the astrobotic Peregrine lander onto the moon. So we shut those engines down again. We are ready to do that, and then start them up one more time in order to do the third burn. And that's what's going to take Celestis's Enterprise mission out to deep space. So let's talk a little bit about where these things happen. We're going to go ahead and shut down the main engines on the Centaur when we get about halfway across the Atlantic Ocean, and then we're going to coast the rest of the way across the Atlantic Ocean, across Africa, and go ahead and start the engines up again when we get to Madagascar. And that's where we'll do the second burn, and then we coast again until we get about to Papua New Guinea. And when we get over Papua New Guinea, that's where we'll go ahead and do that third and final burn.
Okay, so you mentioned a couple of these key milestones that are ahead of us. What can everyone expect to see as far as the timeline of these mission events as they continue watching today?
Yeah, absolutely. So looking at the clock right now, looks like we've got about 2 minutes, a little over 2 minutes left here in the first burn of the upper stage. We're going to coast for about 30 minutes after that as we do that coast across the Atlantic Ocean and across Africa. The second burn will be about 4 minutes long, and then we'll have another coast for 30 minutes before we have a pretty short, like 20-second burn for the final burn. Once we've done that, then we've got some engineering demos we're going to do before we finally safe the stage and shut everything off. And then about 4 days later is when the Centaur will leave the Earth-Moon system and be off on its way to deep space.
Awesome. Well, thank you so much for sharing that with us, and thanks for joining us today. And we'll let you get back to watching those next events.
Absolutely. Thanks so much, Amanda.
Thanks.
The U system is steadily making the correction down to a nominal MR. Or 1 minute, D'Amico. Both engines firing normally.
This is Vulcan Mission Control at T plus 15 minutes 30 seconds. We are approaching the first main engine cutoff. Let's listen in.
Coming up on MECO 1. On to open loop control on MECO. We have cutoff. Both engines show normal shutdown signatures. We have settling established, 85% duty cycle. We are now in a 27-minute, 51-second coast duration to second burn of Centaur.
This is Vulcan Mission Control at T plus 16 minutes 20 seconds. We just heard flight commentator Rob Gannon confirm successful cutoff of the first main engine, and all systems continue to operate nominally. Our next event, Main Engine Start 2, will occur in about 27 minutes. At this time, we'll pass the broadcast back to the NASA team to continue with mission coverage through the coast phase. We'll join you back in as we approach the separation of the Peregrine spacecraft. Over to you, Megan.
Thank you, Amanda. Congratulations to you and the ULA team so far. If you're just joining us, welcome to the Space Coast of Florida, where we just witnessed the first launch of NASA's CLIPS initiative. It was a magnificent sight. Leaves me speechless, apparently. Just really lighting up the night sky and loud enough to set off a couple of car alarms nearby. CLIPS is short for Commercial Lunar Payload Services. It's a new model in which NASA contracts space on commercial missions to send science experiments to the moon ahead of us landing astronauts there. For today's launch, NASA selected Astrobotic to deliver its 5 lunar instruments. This is the first mission for its Peregrine spacecraft. Today was also the first launch of ULA's new Vulcan rocket. Again, congrats. It lifted off from Cape Canaveral Space Force Station's Launch Pad 41. Our broadcast here on NASA TV will continue through Peregrine acquisition of signal, which is expected to happen at the earliest around 3:17 a.m. Eastern Time. With me now is Sandra Connolly. She's the Deputy Associate Administrator of NASA's Science Mission Directorate. Good morning, and thanks for being here, Sandra.
Good morning. It's a thrill to be here.
Yeah, what did you think of the launch?
It was amazing. Yet another beautiful ULA launch. Totally spectacular, and it's super exciting to know that now our Peregrine 1 lander is on its way to the moon, and in about 2.5 weeks it's going to go into orbit. And a few weeks later from that, in mid to late February, we're going to actually see it land. And that will be the first, well, actually it'll be one of the early landings on the moon since Apollo, over 50 years, which is pretty amazing when you think about it. U.S. landings on the moon.
Yeah, it is. And the CLIPS is new as well. So talk to us a little bit about this program. We're using commercial companies to send science instruments to the moon for us. Why is that?
Yeah, I'm really excited about this program. It is a game-changing program for us. It really is leveraging industry in new ways. As you've probably seen, I mean, the whole aerospace industry has evolved over this last decade in amazing ways, and I think this is just yet one more step in doing so. So our commercial partners are actually delivering a service. They're delivering our payloads and other organizational payloads, whether it's other companies, whether it's international partners. Basically, anybody who wants to procure the service can deliver a payload to the moon using the CLIPS program.
And so there are 20 payloads flying on the Peregrine spacecraft right now. 5 of those are NASA's. Can you tell me a little bit about what they'll be studying once they get to the moon?
Yeah, so again, amazing service. So our payloads are going to be studying things, including understanding, studying water, studying the volatiles or the resources on the moon, studying the atmosphere, and also the radiation environment to help inform us for the future when we have humans back on the moon.
Sandra, thank you so much. I'm excited to see what we do with this initiative and this launch here today.
Thank you so much, and let me just say, go Vulcan and go Peregrine 1.
Yes, you could totally say that. Thank you so much.
Thank you.
All right, so when Peregrine lands on the near side of the moon on February 23rd, it will be one of the first lunar landings for the U.S. since the final Apollo mission over 50 years ago. Let's head back over to Astrobotics, Olivia Chapla.
Thanks, Megan, and what a great day so far. So for those of you just tuning in, I wanted to reintroduce myself. I'm Olivia Chapla, Director of Marketing and Communications for Astrobotic. Astrobotic is a space company with our primary headquarters in Pittsburgh, Pennsylvania, and we've just watched our Peregrine lunar lander rocket into space aboard a United Launch Alliance Vulcan rocket. This Peregrine spacecraft's mission is to carry 20 payloads or cargo to the lunar surface from 7 different countries. 6 of those nations have never reached the moon before. Our aim is to autonomously land on the lunar surface a few weeks from now. We're taking the long way around, and we expect Peregrine to land on February 23rd, 2024. We've got all eyes on the Peregrine lander as it waits to separate from the Vulcan rocket in about 30 minutes. At that point, we will seek to establish communications with the lander. And now we'll take a more in-depth look at Peregrine's full journey to the moon with an animation. Once ULA's Vulcan rocket launches, we will then know the exact day the Peregrine spacecraft will attempt a soft landing on the moon. The first landing attempt could be anywhere from 10 to 60 days from launch. Because this is Peregrine's first ever trip to the moon, our team is not taking a direct path. Peregrine will first complete one Earth orbit so the team can get critical data on the spacecraft and test maneuvers before executing a very critical milestone, entering lunar orbit. Peregrine will orbit the moon at 3 altitudes. The first orbit will last about 33 hours. Peregrine's second orbit can be up to 35 days. The spacecraft's third and final orbit around the moon will last 48 hours. Next up, Peregrine will attempt a soft landing on the lunar surface autonomously. The team will issue a landing sequence that will command the spacecraft to enter a descent orbit. About 15 kilometers from the lunar surface, an exciting powered descent begins. While we wait for the Peregrine spacecraft to separate from the Vulcan rocket and begin that exciting journey to the moon, I have Astrobotic's founder and Chief Executive Officer, John Thornton. Hi there, John. I understand you are currently at ULA, just a stone's throw from where I am now, and we both just saw ULA's Vulcan rocket achieve liftoff with our very own Peregrine aboard. Tell me, after waiting for this moment for years, how are you feeling?
It's a dream. This is the moment we've been waiting for 16 years, and I'm standing in mission control, and we just had a beautiful launch. Thank you, ULA. So excited. We are on our way to the moon.
I can tell you and everyone else are in a really excited buzz today for sure. So tell me, what else do you think is the most important thing about our Peregrine mission today?
So this is the beginning of the dawn of a new era for the surface of the moon and how we think about space. This is an opportunity for commercial payloads to fly to the surface of the moon on a regular, routine basis. That means our nation's scientists, our world scientists, can access the moon in ways never before possible. And we are seeing the beginnings of that right now as we speak on our journey to the surface of the moon. Our first mission carries 20 payloads from all over the world. 6 nations on board the mission will touch the surface of the moon for the very first time. It's a phenomenal, exciting mission to be a part of, and it's a real honor to be here today, and I could not imagine a better start to the mission.
That's true. And what do you have to say to the Astrobotic team and to all of the payload customers who made today's mission possible?
For 16 years, we've been pushing for this moment today. And along the way, we had a lot of hard challenges that we had to overcome, and a lot of people doubted us along the way. But our team and the people that supported us believed in the mission, and they created this beautiful moment that we're seeing today, working incredibly hard to make this possible. I can't thank the thousands of people between our team, our suppliers, our partners that have made this moment possible today. It's an unbelievable feat, and it is the culmination of all of everyone's effort coming together for this moment, believing in this possibility that a small company in Pittsburgh, of all places in this country, can lead America back to the surface of the moon.
Thank you, John. Well, I'll let you get back to the team that are in Florida with us as we wait for the Peregrine spacecraft to separate from Vulcan's rocket in about 30 to 40 minutes. For now,
Can't
back
wait.
to
Thanks,
Megan.
Olivia.
Oh, thank you.
Now, CLPS missions are an important step in returning to and staying on the moon. But these lunar landings that will help shape our future there are not without risk. tested the spacecraft here on Earth and what the team will do during its journey in space.
Peregrine has been through quite a journey already and still has a long list of objectives to complete on its way to the moon. We've categorized these objectives into 5 stages, beginning with engineering it here on Earth. First, we built and tested a bolt-for-bolt engineering model of Peregrine. Based on our findings, we constructed the final spacecraft to send to the moon. Each iteration of Peregrine went through rigorous testing to ensure it will survive the harsh conditions of launch and space environments. Phase 2 objectives will begin when the spacecraft separates from the rocket. Once separated, Peregrine will power on and establish communications with Earth. At this stage, we'll receive telemetry informing us of the spacecraft's position, orientation, and general operational health. One of the first commands we send to the spacecraft will initiate thrusters to point Peregrine's solar panels at the sun to charge its battery. We are planning for all of these objectives to be completed today. Next, and off-camera, our Phase 3 objectives begin. These objectives include trajectory adjustment maneuvers in space before lunar orbit insertion. After lunar insertion, Peregrine will complete 3 orbits around the moon. Then, the last phase of the mission begins, lunar landing and operations.
And for a closer look at landing, I'm joined now by Mike Hennessy, Educational Director of the Moonshot Museum in Pittsburgh. Good morning to you.
Good morning. It's spectacular to be here today.
Absolutely. We saw a launch, right?
Yeah, and it was awesome.
Yeah, absolutely. So talk to me about Peregrine and the spacecraft we have you on, because you know a lot about Peregrine and this mission. Why is that?
Well, every day I've had a front row seat at Peregrine under construction. I work at the Moonshot Museum, and we share a wall of windows with Astrobotic. And better yet, I've seen kids with their faces pressed against the glass, knowing they're going to grow up to become that next generation of makers that take us to the moon.
That's fantastic. And you also brought us some props here. So these are different parts, different materials that make up the multi-layer insulation. That's what goes around the spacecraft, right?
Right. That's the thermal protective space blanket for the craft. And we have a number of different materials here. This is Astro Quartz. It's a woven ceramic fiber, very heat resistant. We've got aluminum, which is great for reflecting solar heat. And this is also aluminum. Glitters a little more like gold, but
yes.
It's just aluminum that's been covered with a polymer called Kapton. And you can see it actually on our model here. We have of the Peregrine lander.
Right here. This is the multi-layer insulation.
Yeah, we've got the multi-layer insulation, and that's wrapping these fuel tanks, kind of like cosmic baked potatoes.
And why do we need all these different materials?
Well, the moon is a harsh environment, and it takes a lot of technical know-how to land there. There's no atmospheric blanket like we have on Earth. So we need a thermal space blanket to protect against wild temperature extremes. Boiling hot days, freezing cold nights, several hundred degrees below zero, and Peregrine's been engineered to endure that.
Okay, so now we know how it will be protected during landing. How will it land? What technologies are we using to make sure that it lands safely when you say that the moon isn't the easiest place to land on?
Right, and that's my favorite part of the story because this robot is going to land itself. Because we have about a 2.5 second signal delay from the Earth to the moon and back, it's like having a self-driving car going to another world. We have a full suite of sensors, gyroscopes, Doppler, LiDAR, star trackers, and a really cool technology called Terrain Relative Navigation, or TRN. About 9 miles out, Peregrine will activate its camera, and as it's descending, and the camera is taking pictures, the computer will be playing kind of a high-speed game of flashcards, comparing those pictures to 3D maps, and then Peregrine will have to make decisions in order to come to a landing. We're going to test drive this technology on Peregrine, and then on Astrobotic's next lunar lander, Griffin, TRN will be in the driver's seat when we head to the moon's south pole.
Oh, that's fantastic. And I know Griffin is going to be delivering another NASA payload, so another partnership where we get to do this together.
Yeah, I think another great example of how CLIPS is bringing together entrepreneurship and accelerating the pace of science and taking us out into the solar system.
Mike, thank you so much. Thank you for being here.
Thank you.
All right, so the Astrobotic team hopes to land on the near side of the moon on February 23rd in a place called the Bay of Stickiness, a lunar feature formed by ancient hardened lava flow. It's located outside of the Gruithuisen domes, which is the largest dark spot on the moon. Why does NASA want to conduct science here? Well, on Earth, formations like these domes need significant water and also plate tectonics to form. But without these key elements on the moon, lunar scientists have been left to wonder how the domes formed and evolved over time. We'll, of course, have coverage of the landing on our NASA Plus app or whichever social platform you watch us on. Now, earlier in the show, we told you about the NERVIS payload from NASA's Ames Research Center. The other payload from Ames is the Neutron Spectrometer System, or NSS.
And if you're just joining us, welcome here to the launch pad. We are continuing to monitor T plus 34 minutes into flight of Vulcan. The first stage mission complete. The second stage well on its way, now in a coast phase, as we continue to wait for it to conduct a second burn ahead of its actual deployment. The Peregrine lander beginning its moon. We do have a live tracker up where you can track the latest updates of Peregrine 1. We'll be following it all the way to lunar landing. We're now 45 days away from that lunar landing, as they are targeting February 23rd for touchdown on the lunar surface, but there's many milestones to come prior to that, so we hope that you will track along with us as we await the landing of the first U.S. lunar lander in 50 years. Last time the U.S. landed something was in 1972 at the end of the Apollo era. If it's your first time here, though, take a moment, engage that like button, and subscribe so you never miss another live launch coverage. Docking, undocking, or return to Earth, and I think it's pretty awesome that we get to say, or lunar landing. We're getting to say that more and more often. We've had Chandrayaan 3 and so many others. It just gets more and more exciting as we really are entering this new era of going back to the moon, but this time to stay. Let's get back into NASA coverage as we continue to await Peregrine 1 deployment.
Megan, thank you. It's a wonderful day.
It is. We just watched the launch. What did you think?
It was amazing. Oh my God, what a wonderful feeling. That rocket was gorgeous.
Yeah, and so NASA has 5 payloads hitching a ride. Tell me about the different things that they'll be studying and why they're studying those things.
So this early mission for Eclipse, this is our first mission. So our first 2 early missions are mostly carrying small instruments that help us learn more about the environment at the moon. As we get further into Eclipse in future missions, we'll raise the complexity and start studying more complex, more difficult questions. But at the beginning, we're mostly trying to characterize what the moon is like, what the radiation does, what kind of environment we can find there. It doesn't have an atmosphere, but there's particles and dust and other things. We're trying to get more information about that so that we can help guide future human missions more effectively.
And how soon could we see data from some of those instruments so that we can start creating that fuller picture?
We'll start getting data back within hours of landing on the moon.
Wow.
Now, the scientists will need some time to analyze that information and turn it into the kind of information that helps guide future missions. But we should be getting data back from the moon within a few hours of landing, and we'll all the way for as long as 14 days on the moon. We'll be gathering that data. But the scientists will then take that information offline and analyze it for a while.
So basically these missions, these instruments that we're sending, they're scouting the moon for us.
Yes. Yeah, they're telling us what the moon is like, helping us understand what we need to know so that we can take humans there safely. It also allows us to better design future instruments and other experiments that will pinpoint the kinds of things we need to know about the moon to be able to work and live there.
Chris, thank you so much. Thank you for being here.
You're welcome.
Okay, so we're now less than a few minutes away until the Peregrine spacecraft separates from Vulcan Centaur upper stage. We're going to go back to ULA for that milestone, but before that, another quick status update on Peregrine from Olivia.
Thanks, Megan. And now I'm checking in on Astrobotic's mission control team. In about 20 to 30 minutes, they're expecting Peregrine to power on and then try to communicate with them on the ground. Peregrine will establish ground communications with NASA's Deep Space Network, and then we will begin receiving telemetry. As we wait for those milestones, here's an in-depth look at the inner workings of the Peregrine lunar lander. And now we'll take a look at the Peregrine spacecraft. You'll notice that we've removed the MLI, or multi-layer insulation, so we can better see the inside of the spacecraft. Throughout Peregrine's journey, they'll keep an eye on the spacecraft's temperatures, pressures, power levels, and communication system. Solar panels at the top of Peregrine charge its batteries to power the spacecraft. Moving down towards the center of the spacecraft are the payload decks. You'll notice the decks have a unique isogrid pattern that we've used as an inspiration for a lot of our graphic design for the mission. This structure pattern optimizes the sturdiness of the payload decks while also minimizing its weight. Affixed to these decks are all 20 payloads. 20 individual pieces of cargo from 7 different countries are aboard these 2 main decks. Peregrine has 12 attitude control system engines called thrusters that are used to orient the spacecraft. You can see 4 large propellant tanks filled with monomethyl hydrazine and multiple mixtures of oxygen-nitrogen, or MON, as oxidizer. Mounted to the bottom of the spacecraft are 5 main engines that will slow the craft down as it approaches the lunar surface. These engines use a hypergolic bipropellant pressure-fed system. Believe it or not, Peregrine will use the majority of its fuel in the last 15 minutes of the mission as we attempt a soft landing on the lunar surface. Peregrine has 4 landing legs attached to its base. These legs have a honeycomb structure on the inside that will crush to absorb the impact of Peregrine landing on the lunar surface. Peregrine is designed for an autonomous landing. That means it will use complex computing and a suite of sensors instead of human pilots. There are 2 antenna relays and a high-power transponder to relay communications between the spacecraft and the astrobotic team. The relay will connect Peregrine with NASA's Deep Space Network, or DSN, utilizing the same dishes that communicate with the James Webb Space Telescope as well as other historic missions. And the last major feature of Peregrine is something you can't see. It's the hundreds of people who have worked on, tested, and gotten the spacecraft to the launch pad today. A shout out to the team we like calling the Astrobots, and a shout out to our payload customers who are sending their items to the moon with us. Your continued commitment to science and lunar exploration is important for humanity. The Peregrine lunar lander has 20 pieces of cargo called payloads aboard. You can find the full manifest on the Astrobotics website, but here is a look at a few of the payloads. IRIS rover. This is a student-built rover with a mission to take photos and send them back to Earth as it drives across the lunar landscape. Once Peregrine lands on the moon, IRIS will deploy to the surface to begin its mission. And here we have another Carnegie Mellon University payload called Moonark. Moonark is seen as a cultural museum to the moon. Comprised of 4 independent chambers and weighing a combined total of 10 ounces, it contained hundreds of images, poems, music, nano-objects, and earthly samples. Next, we have Colmena, a fleet of micro-rovers and the first Latin American scientific instrument ever sent to the moon. Consisting of 5 small rovers, it will demonstrate a coordinated moon exploration. Lastly, we have the DHL Moonbox. Former astronaut Richard Garriott and thousands of others from around the world have sent small mementos to link life's meaningful moments with our nearest celestial neighbor. Now, this is just a snippet of the 20 payloads aboard Peregrine. Again, you can find the full list on Astrobotics' website. Now back to Megan.
We are now less than 10 minutes away from Peregrine separation, so let's get back over to the ULA team and Amanda Sterling to take us through that.
Thanks, Megan, and thanks to those of you who are still following mission progress of ULA's Vulcan Cert-1 flight. For those who are just tuning in, I'm Amanda Sterling, and I'm here at ULA's Advanced Spaceflight Operations Center at Cape Canaveral Space Force Station in Florida. ULA's inaugural Vulcan rocket lifted off on its first flight test at 2:18:38 a.m. Eastern, and all systems continue to operate nominally.
Minute, 1 second burn. And we've begun pressurizing the propellant tanks in preparation for second burn. Up on LH2 pre-start. LH2 pre-start.
This is Vulcan Mission Control at T plus 43 minutes, 8 seconds. Coming up next is the second main engine start of ULA's Centaur upper stage. Let's listen in.
Change to the start position, everything looking good. About 15 seconds to mess. We have ignition, full thrust. 2 good engines. Everything looking good.
This is Vulcan Mission Control at T plus 43 minutes 57 seconds. As we approach Peregrine separation, let's learn more about the first spacecraft to launch in NASA's new CLIPS initiative to have American companies send its science experiments to the moon.
Astrobotic is a full-service lunar company. It starts with our terrestrial testing and development services.
And if you're just joining us, welcome here to the launch pad. You can see there we just saw ignition of the Centaur engine, or the second stage of Vulcan, doing a final burn in preparation for payload deployment of the Peregrine lander that will then begin its 45-day journey to the moon. The second burn is expected to last about a total of 4-ish minutes. We'll wait to see the confirmation of that. We are now at that point where we're watching it via renders, but those renders are informed by live time data, and we're getting those updates from ULA Mission Control as well as we continue now 45 minutes into the historic first flight of Vulcan Centaur, and we are just about 5 minutes away from the first ever payload being separated from Vulcan and basically being able to declare Vulcan a first-time launch success. An incredible day. Congratulations to the entire ULA team, the Astrobotic team, and to Blue Origin. Your BE4s have done it. They have launched a rocket to space. I know we were all holding our breath, and super exciting day as we continue to see this next generation and this new era of space exploration really kick off. More and more launch vehicles coming online, it seems, every month, and we're super glad that you chose the launch pad as your live launch coverage. I know there was many opportunities where you could watch the launch tonight, and we are super grateful. If you haven't yet, join us over on X. That's where we post a lot about different space news and stuff, but it's also where our TLP rocket chasers have been posting their photos for this evening's launch. We've had some amazing shots come in from Gavin and Joe. We also do have Eric and Joe's cameras out at the remote site, so make sure you stay tuned for more of those photos coming in over the coming hours, and tomorrow once we're able to retrieve those remote cameras as well. A huge thank you to NASA and ULA for the opportunity to set out those remotes. We are greatly appreciative of having that access, and of course to the Space Force for also allowing us to have that access, as today's launch was on Space Force Station. As we await T-minus 46 minutes, 30 seconds into flight, we are expecting Peregrine separation 50 minutes, 20 seconds into flight. So just a few minutes left until Peregrine begins its journey to the moon. If you want to follow along Peregrine on its journey, we do have our live tracker up and running where you can follow along a rough idea of where it is in orbit on beginning its journey. Peregrine's going to do a full loop back to Earth before it actually enters lunar orbit. Let's listen back into ULA Mission Control.
This is Vulcan Mission Control at T plus 47 minutes 8 seconds. We're a few seconds from the second main engine cutoff. Here's Rob Gannon.
30 seconds to nominal MECO. $20 seconds. And we're going to open loop on PU. Coming up on cutoff. We have cutoff. Everything is looking good. And we are now in a 2-minute 49-second coast phase of spacecraft separation. We've got full settling going after MECO. And we're reorienting to spacecraft SEP attitude.
If you're just joining us, welcome here to the launch pad. We are Counting down the final couple of minutes until Peregrine
And continuing to
separation.
maneuver to our MES 2 attitude.
The second stage of Vulcan, the Centaur stage, maneuvering, preparing to separate that lunar lander, the Peregrine lander, from Astrobotic. That separation is expected 50 minutes, 26 seconds into flight, just over a minute from now. The second stage will then perform a third burn, sending it off on a journey into a solar orbit. It does have a few payloads on board itself, as ULA is launching the DNA of some of their staff, their CEO, and some other people on board, but it's also just
and we're inside a minute and a half of spacecraft separation.
Go, counting down
Body
the
rates are nulling out.
last minute till payload separation.
And this mission does call for a roll spin for spacecraft separation of 0.5 degree per second. We'll be starting that maneuver shortly.
"30 seconds till Peregrine separation."
This is Vulcan Mission Control at T plus 50 minutes 10 seconds. Vulcan has executed all mission events expected, and we are now approaching delivery of the Astrobotic Peregrine commercial lunar lander into a highly elliptical orbit, more than 220,000 miles above Earth to intercept the Moon. Let's return to flight commentator Rob Gannon as we approach separation.
We are spinning down.
Peregrine has separated from Vulcan.
And we are now in a 28-minute coast period, the third burn of Centaur.
Hopefully hear more there, but Peregrine is now on its way, beginning its 45-day journey to the surface of the Moon.
This is Vulcan Mission Control at T plus 51 minutes 6 seconds. We just heard confirmation of Peregrine spacecraft separation. I'm now back with ULA President and CEO Tori Bruno. Tori, our first Vulcan rocket just delivered its first payload to orbit. How are you feeling?
Yeehaw! I am so thrilled. I can't tell you how much.
Absolutely. And again, we're not completely done with the mission here today. Is there anything else that you want to share with the audience?
I am so proud of this team. Oh my gosh, this has been years of hard work. So far, this has been an absolutely beautiful mission back to the Moon and off to our next burn, where we will do our final payload deployment to that heliocentric orbit for the memorial. Our team has done such a good job. Bravo, Zulu to everyone. This is it's hard to describe.
Yeah, absolutely. I feel that too. So again, thank you so much for joining us on our show. Congratulations, and we'll let you get back to finish the rest of the mission.
Congratulations to you. Give me a hug. All right.
And you can see it there, the excitement from the CEO of ULA, Tori Bruno. We'll be excited to hear from him down at the 50th Annual Space Conference, what I'll be attending in just a couple of weeks down in Florida, so make sure you stay tuned. I'm sure we'll hear lots from him there about how this first flight has gone, but Vulcan has done it. Vulcan's first ever flight is a success. They do have these last payload to go into that heliocentric orbit with the sun, but the main payload has been deployed.
Thank you, Amanda, and well done, ULA team. So throughout the broadcast, we have been telling you about the 5 NASA payloads that are flying on this mission. We've shown you in depth 3 of them, and now we have the final 2. So NASA's Goddard Space Flight Center has 2 payloads aboard today's flight, and one of those is the Peregrine Ion Trap Mass Spectrometer, aka PITMAS. Its job is to understand the release and movement of lunar surface volatiles like water.
Investigator, or the
The final NASA payload we want to show you is the Laser Retroreflector, or LRA. It's a unique type of mirror used to measure distance, and this is why it's so critical for future missions. About 55 minutes since Vulcan and Peregrine lifted off from the space coast of Florida. Let's get back to Olivia and the Astrobotic team as they work to confirm acquisition of signal with their spacecraft.
Thanks, Megan. As you saw, we just got confirmation that the Peregrine spacecraft separated from the Vulcan rocket, and now we are waiting to establish a space-to-ground communications connection. We expect for this to take a few more minutes. This connection helps engineers in Astrobotic's Mission Control Center pass commands, receive telemetry, and determine the location of Peregrine in space. Peregrine will be utilizing NASA's Deep Space Network, or DSN. They're 34-meter dishes in Australia, Spain, and California. These dishes are the same suite used to communicate with the James Webb Telescope, as well as other historic missions. So our flight director on console, Alex Van Hoven, will be calling out what is happening in Astrobotic's Mission Control Center. And now, as we look at Astrobotic's Mission Control Center, you can see the rows of our staff all monitoring the spacecraft. In the room today, we have three of six.
This is Mission Control Flight Director announcement. Repeat broadcast, this is Mission Control Flight Director with an announcement. The mission team is still waiting for communications with Peregrine with earliest AOS at 080905 UTC in approximate 2.5 minutes. To repeat, the mission team is still waiting for communication with Peregrine with the earliest AOS expected at 080905 UTC.
And folks, that was Alex Van Hoven, our flight director on console. He is calling out UTC times, or sort of space times, and we're waiting for that acquisition of signal with the Peregrine spacecraft.
Correction, earliest AOS at 0818 UTC. Earliest AOS at 0818 UTC.
Now you can almost see Alex Van Hoven in the back row, right below the eye in Astrobotic. You can kind of see his head. Maybe he'll stand up for us at least one time, we'll see. He's very focused and busy. Today we have 3 of 6 flight directors on console for launch. Once we establish communications with Peregrine and the spacecraft officially begins its journey towards the moon, the flight directors will work in shifts so there is always one present in mission control. I would ask them to all give a wave, but they're definitely laser focused on their screens, checking up on the spacecraft. Now Alex, he's giving us those live updates, and he is also senior aerospace engineer, and he oversaw the development of Peregrine's in-flight procedures. He developed his flight expertise as part of NASA's Goddard Space Flight Center.
Broadcast, Mission Control Flight Director announcement. I repeat, broadcast, Mission Control Flight Director announcement. At this time, Astrobotic has confirmed that we have established communications with Peregrine, and we are now receiving live telemetry. I repeat, we have just established communications with DSN and can confirm that we are receiving telemetry from the satellite.
Now, confirming, my goodness, We have received signal with the Peregrine spacecraft, and we are communicating it with it here on Earth. You just heard it from Alex. The team will begin sending commands to Peregrine to continue its journey to the lunar surface. What an incredible day. Now, thank you so much for continuing to tune in with us to watch this historic launch of Astrobotic's Peregrine lunar lander on its journey to the moon. I'm Olivia Chapla with Astrobotic, and it is such a happy day for Astrobotic. I'm kind of speechless. So back to Megan at the hostess. Thank you very much.
Hey, congratulations, Olivia. I know that must have been really nerve-wracking to see such a big moment and it being finally here. So congratulations to her and the rest of the team. And actually right now here with me, I have Andy Jones, and he is the Director of Landers and Spacecraft for Astrobotic. And Andy, I saw you were over off the camera, but I saw you go, yes, as soon as we confirmed acquisition of signals. So talk us through that. How are you feeling?
Relieved. More than anything else, relieved. I mean, getting communication is just so important to everything else we want to try and do. So now I can start enjoying the moment, enjoying the excitement of getting into space.
Yeah, at least you didn't have to wait long. You know, there was a window, right? We got it right at the beginning of the possible window.
So just a credit to all the great work the team has done to actually get it, to acquire it so fast.
Yeah.
It's just a brilliant set of machine, brilliant people working on it. So
yeah,
very proud.
Yeah, what would you say to the team? You know, again, I know that you guys have been working on this for years. What would you say to them as it culminates in this moment right now?
Get back to work. No,
not even going to give them a break. Okay, we're hard-working folks at Astrobotic, guys.
No, extremely proud. The team should be extremely proud of themselves. It's been a fast road, a lot of setbacks, a lot of ups, lots of downs. The team took everything in their stride and, as you can see, achieved remarkable things. So proud of everybody, what they've done. Inspirational to everybody.
Yeah. And what's next for Astrobotic and NASA? You know, it seems like we're going back to the moon for a second time, huh?
It is. So once obviously successful completion of this mission, we have Griffin, which takes the Viper rover to the moon late 2024. Following that, we have as early as 2026, a tipping point where we do a demonstration of power transmission across the lunar surface. And also, Astrobotic is part of the national team led by Blue Origin to take humans back to the moon, and we're part of the cargo lander system for them.
So a lot of things to look forward to.
Lots to look forward to. Yeah.
And just by one last question for you, I mean, just what do you think of this new initiative that NASA has to really bring in all of these small U.S. companies to hopefully help us all go back to the moon?
This initiative is incredibly important. It allowed a small company like Astrobotic to actually deliver a lander to the moon. We'd have never been able to achieve it without that. But the best thing is it's bringing a lot more creative minds, new thinking to the table, and that will help us accelerate the technologies needed to get us back to the moon and have a robust resource and presence on the moon. So the more, it's very important for us to be there, and it's just helping us get there much faster.
Andy, thank you so much, and congratulations again.
Thank you very much.
And that's going to do it for us here at Kennedy Space Center. Thank you for sharing in the excitement of NASA's first CLIPS launch. Now on its own, the Peregrine spacecraft will coast for an expected arrival at the moon on February 23rd.
And if you're just joining us, welcome here to the launch pad. You can see NASA getting ready to wrap up their coverage, but ULA, Blue Origin, Astrobotic, they all did it. Vulcan has launched for the first time, and hopefully we will see a number more Vulcan flights happen this year as we welcome this new ULA launch vehicle into operations. One more certification flight needed, and then it will be fully operational. We expect to see that later this year. If you haven't yet, here's a replay of the launch. Make sure you subscribe so you never miss another live launch coverage, docking, undocking, return to Earth, or lunar landing. We're tracking Peregrine 1 all the way to the lunar surface, so join us on our 24/7 tracker. But that's going to do it for me from our TLP Canada studio. Congratulations to ULA, Blue Origin, Astrobotic, and NASA. And Vulcan has flown. Now from our TLP Canada studio, my name's Zach, and I will see you next time because space is better together. Good morning.